Hi Calculus 3 students. This is the last part on the exercise in the section 10.2, Calculus with Parametric Curves. So we had this curve. In the previous part, we found the intercepts, the derivatives. We also looked for the intervals of concavity. We looked for vertical and horizontal tangent line. This helped us in sketching the curve, and this sketch is going to be important for this last part. And in the previous part, we found the area bounded by the curve and the y-axis in this region. Now, in this very last part, what we're going to do is we're going to find the arc length. Well, actually, we're not going to find it. We're just going to set up an integral for it. Okay, because as soon as you set up the integral, now the problems become to solve this integral. So either it's an integral that you can find with regular calculus 2 techniques, or you can approximate it with numerically or by using Taylor series. In any case, we want to set up an integral to find this arc length. So how do we do this? Well, in this case, we have to remember that the integral for the arc length, so let's actually give a reminder. So reminder, there. If the curve is traversed once, so if the curve is traversed exactly once, then the arc length, so I'm going to call it L. So the arc length L is going to be the integral from, so it's going to be from alpha to beta. So here actually, one thing we could do is we could set up the problem in calculus 2 perspective. You could say, okay, well, this is the curve from y equal to, or actually, no, let's just go straight to what we have here. So t starts at -2, right? So t is equal to -2. And then it goes until t is equal to 0. And then remember that what we're actually getting is, so yeah, let's actually say like t equals to alpha and t equals to beta of x prime of t squared plus y prime of t squared under a square root dt. Okay, so basically what we have to do is read this integral in our context that's over here. So we start when t is equal to -2, and we end when t is equal to 0. So L is the integral from -2 to 0. And then we have to look at the derivatives and square them. So I'm going to put up a very, very big square root. So notice here that your x prime of t squared is going to be like right here. So it's going to be your 2t plus 2, all of it squared. And your y prime of t squared is this guy. So 6t minus 3t squared, add them up, put them under a square root, dt. And there you are. This is the integral that gives the arc length. I hope this was helpful. This was the last video of this exercise, so next video will be about another section of the course. So see you either in that video or in the course.